Hello everyone, welcome to our session Plugin Development Giving Back to the Community. I'm Kamal, I'm a GD in Flutter and Dart.
And I'm Lara Martin, a mobile developer based in Berlin, also Flutter and Dart GDE.
So moving on, what will you be learning from this talk? You will have a good understanding of plugin, how this plugin or package ecosystem is driven completely by community, the blueprint for creating packages, how to add platform support for your package or plugins, and what is this federated plugins. Finally, you'll also see the checklist for null safety and sample UIs, so stay tuned. Well, when I actually look for packages, I have tons of them on pub.dev. Which one to use? Which is the best? Or is it compatible with all platforms? So we have a slide exclusively talking about how to select or choose the right package. Well, I firmly believe Flutter is a community-driven force, and I always constantly look for ways to contribute. And I think one such contribution which plays a major impact or plays a vital role is the plugin development. Because we use them day in and day out in our Flutter development, and these are built by developers like you and me. I see most of the time plugins are created and available, but not maintained or upgraded frequently, which is one of the reasons it fails big time. So let's see how to overcome this. This session is to emphasize the importance of plugin development and how to make it a one-stop solution for a rich collection of libraries. And just not a collection of libraries, but a collection driven by community. And we also see how the developer community is growing day by day. On to you, Lara, who'll be talking about plugins.
We've been mentioning packages and plugins, but what are they? Packages and plugins are bundles of code that are independent and that provide an implementation for one or several functionalities. You can add these bundles of code to your project to benefit from their functionalities so you don't have to implement the same features yourself. And it's independent of your project. Others can also use those packages and plugins as well. Packages and plugins are very similar. Packages on one hand are written in Dart and only contain Dart. They are pure Dart. They can also be used independently of Flutter. However, it can be that it contains a dependency to Flutter, restricting its use to Flutter only. Plugins, on the other hand, are also written in Dart, but the difference is that plugins contain implementation to support different platforms. For example, if a plugin wants to support Android, it has to provide the Android implementation written in Java or Kotlin. This also applies to other platforms such as iOS, to which you could provide an implementation in Swift or Objective-C. And where can you find packages and plugins? The official repository from Google is pub.dev. Here you can find the official plugins created by the Flutter team from Google, as well as tons of packages and plugins created by the community. Even though on pub.dev you can find lots of packages and plugins, it can happen as well that you cannot find one for your specific use case. Or maybe you have worked very hard in a feature that doesn't exist in Flutter and you believe that this can benefit the community. So you might be wondering, how can I create a package or plugin myself? Now we will guide you through the steps for creating your own plugin from scratch. First, we will show you how to create a plugin to target two platforms, Android and iOS. Then we will show you how to add support for a new platform. In this case, we will be adding support for web. And finally, we will explain you how to create a package. You will see that it's similar to plugins, but less steps. And it's easier once you know how to create a plugin. Creating a plugin supporting all available target platforms is difficult to fit in a talk. Therefore, we chose this time to use an existing plugin as a reference. Specifically, we chose the Share Plus plugin. This is a plugin that allows you to share content from your Flutter application to other platforms. We will look at how to implement one specific case, sharing text, and targeting different platforms. We won't be able to add support for all platforms. However, with the steps that we will show you and having the reference code, you will be able to try it out by yourself. Okay, so how do we start creating a plugin? Let's see. Looking again at the steps, the first thing we are going to do is to create a shared plugin that targets Android and iOS. The first thing we need to do is to create a new Flutter project. To do so, in a terminal, we use the command flutter create to create our new project. Flutter already gives you templates, and there is one for creating plugins, which you can get by adding the template plugin flag. Then we specify the platforms that we are gonna target. For now, we are only targeting Android and iOS. Android supports 2 languages, Java and Kotlin, and iOS supports 2 as well, Swift and Objective-C. Since we are using the Share Plus plugin as a reference, and it has an implementation in Java and Objective-C, we are going to choose those languages today for our plugin as well. And finally, we will add the name of our plugin. We hit enter, and in just some seconds, you have already the skeleton of your plugin. Now that we have the base of the plugin created, we have to configure it. You can open the project that you just created in IntelliJ or VS Code. Open the root path spec YAML to start configuring your plugin. On top of the file, you will find the name of the plugin, followed by a description. The description is very important. Give a short explanation of your plugin. For the versioning, it's best to follow semantic versioning. So we begin at 001. The author field is deprecated. And now, instead of adding the author here, it's advised to create a profile in pub.dev and get verified as a publisher. Also, don't forget to add a URL that points to the documentation, the repository, or a website if you have one for your plugin. Remove unnecessary comments from the file. And at the bottom, find the configuration of the plugin. Here you see that we are targeting 2 platforms. Also, it defines the name of the plugin class for each. And remember that if you rename later the class, you will also have to change the reference here. Now let's look at what this plugin template adds into the lib main.dat file. This is the entry point of your plugin. And here is where you are gonna be defining the methods that you will expose publicly for your users. Now, let's see the contents. We see that there are already a couple of static methods. The first one is a method channel. Method channel are the objects that work as a bridge to allow the communication between the Dart code of your plugin with the platform implementations. The second method is defining a getter called platform version that asynchronously uses the channel to invoke a method called getPlatformVersion and returns the result. Now, how does this work? Let's open the implementation site on Android. This is the Android implementation. Here we have a private field that holds a reference to a method channel, which will be used to communicate with the Dart site. Once the plugin runs, it will call the onAttachedToEngine method, which will create an instance of a method channel and set a method called handler. When the method channel is receiving a call, it will invoke the onMethod call. Here we can look at the name of the method that is being called and then send the appropriate response. For example, when on the Dart side of the plugin we call the getPlatformVersion method, Android is gonna return the version. Now that we know how the platform and Dart communicates, we can start implementing the plugin. On the Dart side, we switch the getPlatformVersion method with another one called share. Our users will be able to use the share method to share text. So here we will use the method channel to invoke a method called share and pass a message as a parameter. Now let's see how we can implement the Android side. For the project to compile, you need to open Android Studio, and when you go to import project, just select the example inside the project that you created and select the Android folder. Then you navigate to the file that defines the implementation for Android. In the onMethod called, we will switch the template code with the actual method call we are expecting. Once we receive a call with method name share, instead of returning anything, we will invoke the native sharing bottom sheet. We will implement the logic for sharing text, make our class to extend from activity aware so we have access to an Android activity for our share logic, finish overriding the necessary methods, get the activity, and fire that intent. This code will open the native share sheet when the method share is invoked from the Dart side. Then we do the same on iOS. For implementing the iOS side, on Xcode, you open the project. Remember that you have to select the sample folder and then you select the workspace there. And now you can implement the code that will trigger a share sheet on iOS as well. And finally, let's quickly predefine the example application that our plugin will include. Since we are creating a plugin to share messages, to keep it simple, we only add a button to demonstrate that it opens the native sharing sheet on each platform. And that's how it looks when running on Android.
We will see how to add plugin or package support for various platforms. We have an option by specifying the platform they support by adding the keys to the platform map and the pubspec YAML file. And let's see how to do this. So here is a snippet from the pubspec file. This file shows the Flutter map for the share plugin, which was created by Lara in the previous section. So as of now, it supports only iOS and Android. If you wish to add plugin implementation for more platforms, then the platform map should be updated accordingly. So let's see how to add for Mac OS and web support as well. So using the same example of the share plugin, we have added the support for the Mac OS and web as well. So it's simple as that. So in order to create a plugin package, we use the template plugin flag with the Flutter create command. So the platform option followed by a comma separated list is to specify the platform that the plugin supports. So the available platforms are Android, iOS, web, Linux, Mac, Windows. If no platform is specified, the resulting project does not support any platform. The org option specify your organization using the reverse domain name notation, and the -a option specifies the language for Android, or -i option specifies the language for iOS. And the third final command is to add the web support in an existing platform. So this was an overview of the commands to address the various platforms.
To add support for web on your plugin, on the same repository folder, we run the command flutter create again and add the template plugin flag, but also add platform web flag. So it creates the necessary code for supporting web. Then you have to update again your pubspec YAML to configure the new platform that you are supporting. First, you have to add the dependency to Flutter web, any dependencies you will need for your plugin, and at the end, on the Flutter platform map, you have to specify again the name of the plugin class for web. Also, you need to specify what's the file name of the Dart class for web, which you will see that it's created inside the lib folder. And open the web Dart file. There you will have again all the template code that is added for supporting web. And all you have to do is the same as we did in Android and iOS. Let's change the get platform version method with the specific code for web to open the native sharing sheet.
Alright, so moving on to creating packages. So we know that what is a plugin. Now let's see what is a package and its creation process. So the main difference between a plugin and a package is that packages are purely written in Dart and you don't need to write any native code, and testing is a breeze. So you might ask me then, why can't we stick to packages all the time? There are some good reasons for it. Imagine there is a 20,000 line native library that does exactly what you want. In that case, you might not want to re-implement that in Dart. Writing a good mobile library is hard. There are many libraries out there for Android and iOS which are already data optimized. So doing so in a pure Dart package is possible, but there is no generic way of being mobile friendly. Thus, you might end up spending significant amount of resources just to solve this problem. So let's stick to plugin if it is necessary, or else let's work on packages. So do write plugins if there is an existing native library that does what you want and it is easy to use. Package creation is pretty simple, and I think if you follow this blueprint, you're good to go to make or publish process simple and less prone to errors. Package creation is pretty simple and straightforward. I think if you follow this blueprint, you're good to go and it makes your publishing process simple and less prone to errors. So first thing we have create, which allows you to create a template and the package name. Configure, you have all the details on your pubspec YAML file with the description, comments, supported platform. I think it's a neat document. That is what the user expects in the end. Then we have the develop, where you actually develop the functionality of the package or the plugin. And then we have the license and the add, which is kind of interchangeable. It is recommended to add document in all packages, readme, changelog, license file, which is very important. And then you have something called update, which is like adding all your GIFs, screenshots, examples that actually aids the developer to have a better understanding of your package or plugin. And finally, the link to the corresponding code repository, which is very important. And the final step in the blueprint is publish. Once you've implemented all these criteria, you can publish your package on pub.dev so that the other developers can easily use it.
Federated plugins are a way of splitting support for different platforms into separate packages. Let's say that Kamal and me can implement the Android and iOS side of a plugin because we are mobile developers and have knowledge on those fields. But we do not have any knowledge about desktop applications for macOS, Linux, or Windows. We also don't know about web. We have some users that would like us to add support for other platforms. How can we do that? Let's say that we found someone that wants to contribute and add support for macOS. Also, we found someone that knows Windows and someone that knows Linux. They can create their own packages, and all together, all of us are creating a plugin that is supporting all the platforms. And that's the idea of Federated Plugins, a way of splitting support for different platforms into separate packages. The Share Plus plugin that we use as a reference is a Federated plugin. Different packages that had the same purpose came together to create one plugin that supported all platforms.
Null safety check. In this slide, we'll be covering two topics. One is why null safety and the checklist for migrating packages to null safety. So if I say why null safety, it's often hard to spot these bugs, say for code. With null safety, it catches the issues immediately. It's been observed that if you take the simple hello world example where if you're comparing the overall size of the compiled code, the uncompressed code size shrunk by 3.5% without doing anything but recompiling with sound null safety. This is because the code size of all the included libraries shrank. For example, the Flutter framework itself shrank by 3.9%. Since we are talking about packages, let's see what are the steps to follow while migrating packages to null safety. First thing, check the dependencies. Check the migrating code in order to make sure that if there is any interdependencies, they are taken care. Use a migrating tool, which is very interactive. You can review the nullability properties that the tool has inferred. Analyze your code. Use pubget and then dart analyze. Test. Run your test and make sure that they pass. And finally, publish it. When the migration is complete and the tests are passing, you can publish your package. Then moving on to the pub commands, these are some of the commands that you need to know while you are doing a package creation process. So the first one being the cache or the deps. So cache is used to add packages to your cache or perform a clean reinstall of all your packages in your cache. Then deps list all the dependency used by the current package. Downgrade retrieves the lowest version of all the packages that are listed as dependency used by the current package. Outdated determines which package dependencies are out of date. So it's always good to have a good understanding of these commands and use them appropriately. Alright, so moving on to the sample UIs, where I have used the packages from the pub.dev. So the first one being the flip card, where its property is just to flip the card and display some content. So just to bring the creative side of it, I thought of as a business card, where on one side you get your bio details and the other side you could add the social content. Then moving on to the next package that I've used, it's a slider. So it's a combination of images, slider and rating. So I thought, okay, as and when I slide, the stars or the feedback should be updated. So instead of having the normal text feedback, this is more interactive because at the end of the day, you want your users to be happy with the kind of user interaction they are getting using your app. So this is more interactive, fun way of adding feedbacks. The next one is a simple staggered grid view where you have this staggered layouts. So this is also a nice way of getting your images, or if you have any of the banners or content or event details to be displayed in a staggered view, you can use this package. And then finally we have the Flutter Sparkline. So these are simple graphs, and calculating them and making it a dashboard was another interesting part of these packages. So at the end of the day, you have tons of packages available, but the best part is how do you get them and make it into one single piece to make your app more functioning and also make an interactive.
To recap, you've learned what are plugins and how to create one targeting mobile platforms, and then how to add support for a new platform. Also, we had an overview on packages and how the community comes together to create plugins that support all platforms. And finally, we talked about the importance of null safety and why you should use it.
Thanks for watching our session on plugin development. Thank you.
Thank you.